In this video, we want to look at some algebra review. We're going to be covering various things with fractions and factoring and radicals and simplifying fractions and all kinds of different things, just to kind of get our brain going again, get us back into some of the stuff that we did in algebra. So the first thing we want to look at is factoring. So we want to talk about two things. One, greatest common factor. So if you have something with a greatest common factor, you always want to look to see, can you take out that greatest common factor before you try to factor the polynomial. Now, once we have a trinomial, we want to think of two numbers that add to give us the middle term and multiply to give us the last term. So the numbers that multiply to give us 15 would be 3 and 5. 3 and 5 we can get 2. We then need to figure out what are the plus and minuses. It is a positive 2, so the 5 would have to be negative or positive, and the 3 would have to be negative. If the number in front of our x squared is not a perfect square, or excuse me, the number in front is not 1, we have 4x squared minus 7x minus 2. We now want to think of the factors of 4, which are 2 and 2 and 1 and 4. And we now want to factor that. The factors of 2 are 1 and 2. So we want to figure out how can we get that. So you want to think of all the different possibilities. We could put 2x, 2x, and then we can do 2 and 1 or 1 and 2 as our last terms to see which one that works. Now, right away we can see that that will not work. Our original polynomial had no common factors. That means our answer can have no common factors. Well, if I put a 2 here, I would have common factors. That doesn't work. If I would put a 2 there, that would be common factors, so that doesn't work. So that tells me I cannot use 2 and 2. So my two binomials are going to be 4x and x. And then I want to figure out how can I use 1 and 2. So it could be 1, 2, 2, 1, in that way. Now I need to get 8. So you want to figure out, okay, how can I get 8 there? And I can see my outside term is 8, my inside term is 1, to see that this is 2 and 1. I need a negative 7, so that's negative, that's positive, and there are my two factors. As we move on to fractions, we want to think about, we want to get common denominators. So in a case like this, we have 8v and 4v. So to get common denominators, I can just multiply over here by 2 over 2. Think of this to distribute. So this is u minus v over 8v is 6u minus 2v over 8v. And now if we combine our like terms, our bottom is just 8v. And on the top I have u plus 6u is 7u minus 3v. And there is nothing we can cancel there. Remember, if you want to think about can you cancel, you want to divide this into two fractions to try to decide if you can cancel. Now, yes, you can now cancel on the right part and get rid of the v, but then your final answer would look something like that, which is really not any better, so we'll just leave it like that. So unless you can cancel something with every single term, we don't look to cancel. Another fraction. Similar, we can think x squared minus 9, that can factor into x plus 3, x minus 3. So that tells us that over here, we need to multiply by x minus 3 on the top and the bottom. That means our denominator becomes x plus 3, x minus 3. On the top, we get x minus 3 minus 2x, which means this is minus x minus 3 over x plus 3, x minus 3. Now, look at that. That looks really close. Negative x minus 3 on the top looks like that should be able to factor, but I'm going to have to rewrite that a little bit. I'm going to factor out a negative 1, and then that will give me x plus 3. And if you need a second, you can look at that and think about if you multiplied that -1 back through, how those are equal. Now I have x plus 3, x minus 3, and we can see that the x plus 3's cancel, so our final answer is -1 over x minus 3. So we're dealing with getting common denominators, we're dealing with factoring, we're dealing with simplifying. Now let's talk a little about compound fractions. One of the keys when you have a compound fraction is to consider this two separate fractions. So the first thing I want to do is I just want to simplify the top into a single fraction. So my common denominator would be x plus 2. So I multiply by x plus 2 on the top and the bottom, which this would give me 3x plus 6 minus 18 all over x plus 2, which would then be 3x minus 12 over x plus 2, which would be then 3x minus 4 over x plus 2. So the first thing we want to do, get the top as a single fraction. The next thing we want to do is we want to work on the bottom. Make that a single fraction. So x minus 3 over x minus 3. That gives me x minus 3 minus 1 over x minus 3, which is x minus 4 over x minus 3. Now, once we get there, we can then get our fraction over a fraction. And once you end up with a fraction over a fraction, you can now do the next step, which dividing fractions, you want to flip and multiply. So we flip the bottom and multiply. And one of the things that really is going to be important this year is when doing your algebra is write things out clearly. So you can clearly see what's happening, where terms are going, and what's happening. As much as you try to skip a step and not write everything out, that's when mistakes happen. That's when things get messed up. So here you can see the x minus 4's cancel. And so we're left with 3 times x minus 3 on the top and 3 times x plus 2 on the bottom. So let's next talk about some radicals. Remember, when we have a radical, we can have something like the cubed root of -8, which would be -2. You're looking at a number multiplied by itself. And something like the square root of 27, that is not a perfect square root. So we want to think, what perfect square root goes into 27? You know, our 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and this is 9 times 3. The part that is not a perfect square stays underneath the radical. The part that is a perfect square, we take the square root of that, which is 3, and then that goes in front. So we get 3 square root of 3. So square root of 24, cube root of 24. Once again, not a perfect cube, but we think of our perfect cubes, 8 and 3. If our perfect squares are 1, 4, 9, 16, 25, our perfect cubes are 1, 8, 27, 64. We don't have to know as many of those. So 3 is not a perfect cube, so that stays underneath the radical. 8 is a perfect cube, and the cube root of 8 is 2, so it simplifies like that. If you remember our rules of radicals, the addition of radicals, they have to have the same radical. They both have to be the same root, square root, cube root, and the radicand underneath the radical has to be the same. So 8, once again, not a perfect square. This is 4 times 2, which would mean this is 2 square root of 2. The square root of 4 is 2, and 2 is not a perfect square, so it stays underneath. 18 is 9 times 2, so the perfect square of 9 is 3. The 2 stays underneath, and now they have the same radicand, 2, and they have the same root. They're both the square roots. So in that case, I can just add these together. I'm going to get the square root of 2, and I have 2 square root of 2 and 3 square root of 2, which gives me 5 square root of 2. Knowing our perfect squares and perfect cubes is the key to doing these. If we multiply two radicals and they both have the same radicand, both have the same radical square root, all we can do is multiply what's underneath. 2 times 3 gives me square root of 6. If I have different radicands, what's underneath, and I have different roots, we essentially will say, nope, we can't do that. Okay? Now, mathematically, we will not necessarily do this unless asked, but if you remember, a cube root can be written as a 1/3 power, and a square root can be written as a 1/2 power. So we could rewrite this, and we could change, think common denominators. We could change 1/3 to 2/6 and 1/2 to 3/6. Now, when I multiply both of these, technically are the 6th root of 5 squared times the 6th root of 3 cubed. So this technically would be 6th root of 25 times 27. So you could do that, okay? Generally speaking, we'll just think of it like this. We are not do this down here at the bottom. Is that mathematically correct? Yes. We usually do not look at it from that way, though, even though that is correct. If we have something that we have like this, the radicand square the cube root of negative 54 x to the 8, y to the 9th. The number will work the same way. What is a perfect cube that goes into 54? That would be 27 times 2. 2 is not a perfect cube, so that stays underneath the radical. 27 is a perfect cube, that is 3. To deal with the variables, we look at it this way. We have a cube root. We say 3 goes into 8 how many times? Twice. So that's x squared, because 3 went into 8 twice. And there would be 2 left over. That stays underneath, right? Think if you were doing long division, 3 into 8, it goes in twice, is 6. You're left with 2. That's where we get our numbers. Now, if we look at the 9, 3 goes into 9 division. How many times 3 with none left over? So we will just have a y cubed on the outside. Okay. So that's how you want to do those when you are simplifying a radical that's not necessarily a perfect square or perfect cube. The next thing we want to talk about is rationalizing the denominator. And this is not something that mathematically as important, but rationalizing the denominator is the idea. If we have square root of 2 on the bottom, if you wanted to actually divide that, think long division by hand, which we wouldn't do, we'd use a calculator, but sometimes we got variables, we have to use these kind of tools. We would multiply by the square root of 2 over the square root of 2. What that does on the bottom is that is just 2. So we can rewrite that as the square root of 2 over 2. So if you think about why you want to do that, remember the square root of 2 is 1.41421335. It's on the back of my room right now. So if we have 1 over square root of 2, you would want to be doing the long division of 1.41421335 ... divided into 1. That's really hard when you have the ... there. However, if we rewrote this as the square root of 2 over 2, we would have 2 divided into 1.41421335. You're now able to do that long division, much better. Not that we're going to do that. That's where it comes from. That's the idea. So if we have 3 over the square root of 8, we want to rationalize the denominator. There's 2 ways you could do this. One, you could just multiply by the square root of 2, which would give me 3 square root of 2, and on the bottom, the square root of 16, which is 3 square root of 2 over 4. That would work. Another way you could do this, if you follow the same pattern I did up here by multiplying by the same thing, you could say, well, couldn't we just multiply by the square root of 8? And absolutely, we could. And that would give us that fraction. However, that fraction is not simplified completely because, as we talked about earlier, 2 square root of 2 is equal to square root of 8. So this would give me 6 square root of 2 over 8. And then if I simplify that fraction, I end up with the same thing. So different ways of simplifying the fraction. All right. The last thing we're going to look at is when we want to rationalize the denominator, but we do not just have a single radical. Let's say we have 2 divided by 1 plus the square root of 7. What we're going to do is multiply by what's known as the conjugate. And you may remember this idea of a conjugate. We really talked about the conjugate when we looked at complex numbers. One of the great things about calculus is we do not need to use anything with complex numbers. There's no I involved. So if 2 plus 3i, its complex conjugate would be 2 minus 3i. And why we would multiply that is when we FOIL it, when you multiply by the conjugate, my first term is 4, my outside term is minus 6i, my inside term is plus 6i, and then I get minus 3i squared. What always happens is the middle terms cancel. And if you remember, I squared is a negative 1, so this would be plus 3. So by multiplying by the conjugate, that would be 3, so this would be 9, that would be 13. When you multiply by the conjugate, you lose the i's. They cancel out. So if we multiply by the conjugate here, we're going to lose the radical. So our conjugate would be 1 minus the square root of 7. So by multiplying by 1 minus the square root of 7, the top to that, which we still have a radical, but that's okay. But if I FOIL the bottom, notice what happens. My first is 1, my outside is minus the square root of 7, my inside is plus the square root of 7, and then I get minus square root of 7 squared. So what always happens? Inside and outside terms cancel. We have 1 minus the square root of 7 squared is just 7, so we get minus 6. We could simplify this by taking 2 out of everything to get to there. And depending on how you deal with negatives, right, you could get at something different. We could say this is the same fraction. If we just multiplied everything by negative 1, we could switch it. That would be equal. So anytime we have something that looks like this, that's what we're going to do. We're going to multiply. Anytime you have radicals on the bottom with pluses or minuses, you are going to multiply by the complex conjugate. So what that will mean is if we multiplied this out, the denominator, this would cancel. And I'll leave it for you to figure this out, to actually FOIL the top and the bottom. The bottom, all the radicals cancel, and we just get negative 3. The tops, if you simplify that, you will end up with a radical, and I think we end up with 7 plus 2 square root of 10. So if you wanted to try that one, you could. So rationalizing the denominator, you multiply, so you no longer have radicals in the bottom. One more kind of problem we will see here is something where we have a radical on the bottom like x minus 2. Now, many times we will see this, and why this happens was something for a later discussion, but we'll end up with a x minus 2 on the bottom and an square root of x minus 2 on the top. So if we get a common denominator, we're going to multiply by the square root of x minus 2 on the right side. So what that will do is my common denominator is square root of x minus 2. And what happens over here is we get the same denominator. These two cancel and simplify down to just x minus 2. Now we are able to combine like terms. We can simplify this, and we will have a square root. Our denominator will just be the square root of x minus 2. And then if we wanted to rationalize rationalize the denominator, we can multiply again. This case, it's not so much about rationalizing the denominator, but it's about combining these two fractions. All right, that is all the video is today. The homework over this section is on delta